Chapter 15, Problem 9. Based on the following data, what is the order for the reactant? So what are we given here is time, but specifically, if you note, it's giving us half-lives versus concentration. So we need to understand, how does half-life relate to the order of the reactant? So we can delineate the first half-life, second half-life, and third half-life, and then of course there's fourth, fifth, etc., based on where in the reaction are we. So the first half-life is referring to when you start at 100%, so right at the very beginning, and how much time it takes to get to 50%. Second, now you're starting at 50, you're going to 25, 25 to 12.5, etc., etc. Well, if you look at zero order, the first half-life took 100 seconds, but the second half-life is 50 seconds, and then the third half-life is 25 seconds. So not only should we note that it's getting shorter, but it's also decreasing by 1/2. For first order, it takes 100 seconds for all three half-lives. So every single one would be 100 seconds. So it's staying constant regardless of where we are in the course of the reaction. For second order, it went from 100 seconds to 200 seconds to 400 seconds. So that's definitely getting longer, but noteworthy, it's doubling each time. Okay, so now if we look at the data on the table, half-lives is down on the x-axis. The distance between here and here, that's our first half-life. And then the distance between here and here is our second, third, fourth, fifth. And what we should note is they're all the same. So if they're all the same, that's first order. So if it was zero order, the first one, let's say, would be here, but then the second one would be halfway, and then the third one even less, the fourth one, etc. So notice that the distance between the half-lives gets shorter. If it's second order, if the first one is here, then the second one would be further, and then further, etc. They're getting further apart. But this question was looking at a first order.